Okay, I'm going to go through and work the homework assignment for the average and instantaneous rates of change. Uh, Very few people had problems with part A, the average rate. That's just evaluating the function at these 2 points and taking the difference and then divide by the difference in the x values. But I'll do one or two of those just to make sure you're okay. So people seem to have a problem with part B in each of these, so I'm going to make sure I do all of part B. Then I'll use the calculator to show you a way of doing part A on the calculator. The equation of the tangent line, the tricky part for this is part B. So once you get part B, this one's pretty straightforward. That just goes back to algebra. So for problem 1, the function is f of x equals 5x plus 3. And for B, we want to know what happens when x equals 2. Now this is a linear function, so we know the slope is constant on that. So the slope at 2 is going to be the same as the slope is anywhere else. So we know what that is. It's going to be 5, but let's work it out here. So we'll start by setting it up this way. As h goes to 0 of f of x plus h minus f of x, all divided by h. So let me set that up. H goes to 0. Now wherever I have an x in the original function, for the first part I'm going to replace it with x plus h. So this becomes 5x plus h plus 3. And then I'm going to subtract the original function from that. 5x plus 3. And then I'm going to divide that by h. All divided by h. So I'll rewrite this line. The limit as h goes to 0. Move over a little bit. Now distribute the 5 across that and you get 5x plus 5h plus 3 minus 5x plus 3. And this is all divided by h. And you continue writing this limit until you eliminate the h. So this becomes 5x plus 5h plus 3 minus 5x minus 3 all over h. Now 5x minus 5x cancels out. The 3's cancel out. And you're just left with 5h divided by h. You can divide the h's out and you're just left with 5. So the answer becomes the instantaneous rate of change at x equals 2 is 5. Now as a rule we would have an x left in here and we just plug this x value into it, but this is a constant, it's 5. It doesn't matter what the x is, the rate of change will be 5. Now suppose you wanted to do that on your calculator. Well, the simplest way to do it is take your calculator, turn it on, reset it, now go into the equation editor and put the function in, 5x minus 3, or plus 3 rather. Now if we look at the table, we're asking to find the average rate of change between x equals 5, this would be part A, x equals 1, and x equals 5. So what this would be is f of 5 minus f of 1 all divided by 5 minus 1. Now you can plug these values into the original function and get your values, or just go to the calculator. When x is 5, the function value is 28. This becomes 28. At 1, the function value is 8. And 5 minus 1 is 4. So this becomes 20 divided by 4. That equals 5. Therefore, the average rate of change is 5. And you're done. Okay, the next problem on our list is number 2. Now again, I'm going to do b first. So the function is x squared minus 3. F of x equals x squared minus 3. And b wants to know what the change is at 1. So we're going to start the same way. The limit as h goes to 0 of f of x plus h minus f of x, all divided by h. Okay, so let's plug in the values there. Now once again, wherever we had an x in the original function, we're going to replace that with x plus h. Minus 3. Now I was working one of these for one of your classmates, and I copied the problem incorrectly. And she kept telling me something was wrong, but I couldn't see what it was. And then later on, I was talking to another student, and he pointed out that I wrote it down wrong. So I'm going to have to check myself on those. Divided by h. Now notice, we're going to square x plus h. That's a binomial, so we have to be careful when we square those. This is going to give us x squared plus 2hx plus h squared minus 3 minus x squared minus 3. And that's all over h. So now we have the limit as h goes to 0 of x squared plus 2hx plus h squared minus 3 minus x squared plus 3 all over h. The x squareds cancel out. The 3's cancel. And this h divides out here. And this is a square, so I'm left with h. So now we're going to take the limit as h goes to 0 of 2x plus h. Now when h goes to 0, this goes to 0. Now I'm just left with 2x. So therefore, the instantaneous rate of change is 2x. But I need to know what it is at 1, so I'm going to replace this 1 at x equals 1. That implies 2 times 1, which is 2. Okay, let's see if we can squeeze one more into this before I lose the time. So we have problem number 3. And 3 is f of x equals x squared minus 5x plus 4. And we're concerned about what happens when x equals 3. So once again, we have the limit as h goes to 0 of f of x plus h minus f of x all over h. This becomes the limit as h goes to 0 of x plus h squared minus 5 times x plus h plus 4 minus x squared minus 5x plus 4 all divided by h. So this is the limit as h goes to 0 of x squared plus 2hx plus h squared minus 5x minus 5h plus 4 minus x squared minus 5x plus 4 all over h. This becomes the limit as h goes to 0. Now if we come back up here, the x squares cancel out, the 5x's cancel out, and the 4's cancel out. So I'm just left with 2hx plus h squared minus 5h all over h. This h cancels, one of those cancels, and this one cancels. So now I'm left with the limit as h goes to 0 of 2x plus h minus 5. And as this goes to 0, this becomes 2x minus 5. Therefore, the instantaneous rate of change of f of x is 2x minus 5. But I'm concerned about what happens when x is 3. So that means the instantaneous rate of change of f of 3 is 2 times 3 minus 5, which is 6 minus 5, and that's 1. Okay, I'm going to stop there because my tape might fill up on me, and I will start a different tape in just a moment.